Hola everyone! Before we embark on our journey to learn motion, I thought it might be best to revisit some topics that you might or might not have come across before. Let's begin our discussion with what SI units are. Standing for the International System of Units, it's essentially a standard agreed upon by the scientific and engineering community for measuring things, with the intent being that everyone across the world is communicating and measuring dimensions such as mass, length, and time in the same units to avoid confusion. Now there are 7 base dimensions that make up the full list of the SI dimensions, which can be combined together to represent other physical quantities. For the purposes of this course, however, most of the units that we'll be working with will be in relation to the dimensions of time, mass, and length, where time will be measured in seconds, or s, length will be in meters, or m, and mass will be measured in kilograms, or kg. All the other quantities that we will discuss in this course, such as force, or power, or work, will be a combination of mass, length, and time. And therefore the units for these physical quantities, such as force, power, or work, will be some combination of meters, kilograms, and seconds. There will be plenty of times where we might come across length, mass, and time not being expressed in SI units, in which case we'll have to convert the units that we're given back into SI units. So let's take a look at some common conversions that we might come across. Let's say we stepped on the scales and the scales read 140 pounds. How would we express this mass in SI units? Well, if we did a quick Google search, we would find that 1 kilogram is equal to 2.2 pounds, or at least approximately 2.2 pounds. So to convert from pounds to kilograms, I would have to divide my pound value, or my mass in pounds, by 2.2 to get me a kilogram value. And that would look something like this. 140 pounds divided by 2.2 pounds per kilogram. And this would give us 63.5, and then we could look at the units in isolation, so it would be pounds divided by pounds over kilogram. And remember, when we divide fractions, all we do is flip the denominator with the numerator, so we get 63.5 pounds times kilograms over pounds, where these terms would cancel out and we would get 63.5 kilograms. Let's look at another common one. What if we were to look at our speedometer and we saw a speed reading of 90 kilometers per hour? If we go up to our SI units, we don't see any kilometers or hours, because the dimensions we're looking at are meters and seconds when we consider time and length, which is actually what velocity or speed is measured in. Speed is just the change in distance over time, and we know distance is a length, and we know time is in seconds, so we must have a measurement that's in meters per second. So how do we go about converting this 90 kilometers an hour into something that looks a little bit more akin to meters per second? Well, 1 kilometer is equal to 1,000 meters, and 1 hour has 60 minutes in it, and each minute has 60 seconds. So we can convert this 60 minutes into 60 times 60 seconds, so we know there's 3,600 seconds in 1 hour, and we know there's 1,000 meters in 1 kilometer. So we can go ahead and use that information and convert this into meters per second, because we can say there's 90,000 meters being traveled in 1 hour, which is 3,600 seconds. So we can go 90 times 10 to the 3 divided by 3,600 to give us, and that'll be meters and that'll be seconds, to give us 25 meters per second. Now, quite often we'll also be given suffixes such as kilo or mega or giga that will be in front of the unit, and that'll refer to the magnitude of that unit. So for example, I mentioned 90 kilometers per hour. The kilo is the suffix, and it corresponds to 1,000 multiplied by the base unit. So kilo corresponds to a power of 10 to the 3. Mega corresponds to 10 to the 6. And giga corresponds to 10 to the 9. Similarly, you can go the other way, and we can say milli corresponds to 10 to the negative 3. Micro, which corresponds to 10 to the negative 6. And nano, which corresponds to 10 to the negative 9. And these suffixes are important because not all physical interactions occur in a manner where it's easy to write them in terms of kilograms or seconds or meters. For example, when you're dealing with planets, those interactions happen over thousands and thousands of years. So it's not practical in everyday language to refer to these as happening in seconds. Therefore, that information is given to us in terms of years. Similarly, a car crash doesn't happen over a period of thousands of seconds. It happens within milliseconds. Therefore, it's important to represent that information with the correct prefix. So as long as you're aware of the dimensions, units, and prefixes, then the conversions won't be too difficult to do, and you won't get too confused. So that brings us to the end of this class, and I'll catch you at the next one.